Started here with your 2.5 notes today. It won't be too terribly long because as you can see it's just this one page. You will definitely want to have your calculators out because we're going to use these, or we're going to use our calculators to help determine basically whether or not a set of data can be considered approximately normal. Okay? So, how we can go about doing that? Well, in this class, what we've done with data before is, one of the ways we could actually take a look at a set of data is graph it. Okay? Probably one of the easiest ways, well, I don't want to say easiest, but one of the ways that we could graph data and take a look at it is do a histogram. We can make a histogram of our data and start to see, well, does it look symmetric? Does it start to look like a normal distribution? Now, if it starts to, then we can also start to look at how many data points land between 1, 2, and 3 standard deviations of the mean. And we can use that 68, 95, 99.7 rule. Okay. Now, if we're still not convinced whether or not it's approximately normal, there's a normal probability plot that you can do to actually check on this how symmetric, and not only symmetric, if or not your data can be considered approximately normal. Now, knowing how to calculate out all the individual data points is not important, but understanding how the graph looks like and interpreting its appearance is. So how a normal probability plot works is this. What it does is it graphs your scores. So it takes your values and it puts it on the x-axis. So it takes your data, puts it on the x-axis, and then it gives it a corresponding z-score. And the corresponding z-score basically is determined by the percentile it would be in the list from smallest to greatest. Now I know in percentiles if we have scores that repeat, we go to the one that's lowest, but it makes the assumption that all scores or all data points are basically different. So you'll see like a x value that will have like 4 z-scores with it, or 5 z-scores with it, okay? Because it's assigning a different z-score to every single data point within the list. Okay? So we know our z-scores basically go from -3 to 3 standard deviations. So now, if something is symmetric, and we start to look at where our data points land 0, 1, 2, 3 standard deviations away from the mean, if it's truly symmetric, okay, we're going to cross the x-axis right here at the center. Likewise, as we start to plot the data, what will happen is our data will start to form a nice linear pattern. So if the data is normal, then the following things will be true about our normal probability plot. Is this already down to the very bottom? That's interesting. Hang on here for a second. Sometimes this gets a little glitchy. Yeah, there it did. So, if the data is normal, then 1, our graph, or our normal probability plot, will be linear. The graph will cross the x-axis at the center of the line. And 3, the spread of scores above and below the x-axis will be about the same. So there's three things I'll kind of take a look at. First of all, does it form roughly a nice linear pattern? Okay. Does it cross right around the center? And then last but not least, this is something that I haven't drawn, is the spread above the x-axis roughly the spread below the x-axis? Of course, probably have to throw another point here just to make it look a little bit better. Now, they don't have to be exact, okay? Meaning, when I look at a linear pattern, okay, does a line seem to fit the data pretty well? Okay. When we're talking about the spread, doesn't have to be, 5 and 5. It can be, 6.5 and 6, or 7 and 8. Okay? They can be close to each other and still be okay. What will happen is sometimes if you have a distribution that is clearly skewed in one direction or the other, the normal probability plot will definitely have it show up. What will happen is this. If your normal probability plot, if you have a lot of data points really bunched together at the beginning and then spread out at the end, you can get what's called that would be a, whoops, I forgot to finish off, skewed to the right. Because the distribution is more spread out up top than it is down below. But a normal probability plot skewed to the left will have a large spread below the x-axis and a very narrow one up top. So this spread is much larger than this spread here. This would be skewed right. Oh, I'm sorry, not right, sorry, left. So sometimes you'll actually be given what these distributions look like. Other times, you'll be asked to produce them. So what I've done here is in our notes is I have the screen up here on how you want to set up your calculator, and I have two examples. One which will give you a nice normal probability plot, or that will be a distribution that's approximately normal, and the other that is not. So what I'd like you to do right now is take out your calculator, enter this first example in list 1, and this second example in list 2. I'm going to give you a couple minutes to do that. I'm just going to pause the video here for a second. I just got to make sure I find the pause. Be good. Alright, so hopefully you have all your data into your calculator. So just to show you here, if I go to my stat and I go to my edit, I've entered in all the data points myself into list 1 and list 2. So if you look at your notes, it has the stat plot screen on. So if I go second y equals, it goes to my stat plot menu. Now, one of the things you need to be careful about again is I only want to do one stat plot at a time. And some of you, depending on the last time you were in this menu, if you were in this menu when we did like the 1.7 notes, you might have 2 stat plots on. Okay? You might not have any on. So one of the things I just am going to do right now is, if you're following along, go to 4, hit 4 where it will say stat plots off, hit enter. This is going to shut them all off. I'm doing that on purpose so that when we hit graph, we don't get any errors, hopefully. So now, when I go back to my stat plot menu, second y equals, I'm going to, notice how they're all now off, off, off. I'm going to select the first one, however, and highlight on and hit enter and turn it on. So now, use my down arrow one time, the type of graph. If you look at your notes, notice how the last one is shaded in. That's your normal probability plot. So I select that one, hit enter, scroll down to the data list that I want to do, which is list 1, second one. If you have this as your menu, and this is the only plot up here that's highlighted, you should be good to go. If other ones of these are highlighted, that means you have them on. So now, if I hit graph, this is going to be interesting because I know I'm going to get part of mine to show up, but some of you aren't going to get anything to show up. Some of you might get a different part of the graph to show up.
Zoom 9.
Okay? So as Carter just stated, to get it to fit into the window, zoom 9. Zoom 9. It will fit right smack in the middle of the window. And you really want to make sure you have this, because if it's not in the middle or fitting the whole screen, you know, crossing the x-axis about right in the center, looks like it's doing that. Okay. So now, when I go to sketch this, okay, I'm going to use the trace key and just get a couple key points. Usually when I'm sketching it, I use 3 points. I use the lowest point, I look at where it crosses the x-axis, and the highest point. So the lowest point is at 1, negative 2.14. So when I go to sketch this, I can start to see my window. Well, if I think about my window here, and my graph, well, since my x-axis represents z-scores, I know that I can go 1, 2, 3 standard deviations away, and I should be good. Same thing in the other direction, negative 1, 2, 3. Remember, these are my data points, so these are my x values, whatever they represent. Well, my first point starts at 1, goes all the way out here to 12. So I might have it be right here at the end at 12. My first data point was at negative 2.14. So I'm just estimating where that is. Whoops. If I go to my graphing calculator here, it's nice and big. Okay. What I want to look at is about where is this crossing the x-axis. So since I'm still on trace, I use my right arrow, and I'm looking at, oh, right there, 6, 0. Beautiful. So I'm going to remember 6. I go up here, and it's at 12 and 2.14. So, 1, 2, 3. So 6 is a little bit more here. And then at 12, it was at 2.14. Now, the rest of the points don't have to be perfectly drawn, but I would just like to see, you know, if there's like some major curvage going on, then put it in there. But for the most part, this is making a fairly nice linear pattern. So, I still want to answer this question. So it says, is this data set approximately normal?
Yeah.
Yes. Why? Or explain. Well, our normal probability plot is fairly linear and crossing the x-axis in the center of the graph. The spread of scores above and below the x-axis is about the same. They're not exact, but they're close. Because if I look here, I'm basically going from 6 to 1 versus 6 to 12. A little bit or longer up top, but by one value, not a significant amount. It's definitely looking more linear than skewed in one direction than the other. All right, are you ready to do the second one?
Yeah.
So on the second one, some of you might have even seen when entering this in, wow, you had a lot of low values and then a few values that increased significantly. So as I start to take a look at this particular graph, perfect. So I can go to my calculator. So when I go to my stat plot, I'm going to still stick with the first one here, but I'm going to change it from list 1 to list 2. Now some students sometimes just go ahead and hit graph, and they can get themselves in a little bit of trouble, because is this my entire data set?
No.
No, it goes from 0 to 12 because that's my old scale from my previous graph. And I have data points that are much bigger than 12. So again, don't forget the zoom 9. Ooh. If you look at this one here, okay, we're starting to see all sorts of different things going on here. So some of the things I'm going to note. It starts at 2, and it's at negative 2.17. It's crossing the x-axis basically in between 4 and 5. So there's 4, there's 5. So between 4 and 5, it's crossing the x-axis. And then it spreads way out here at all the way out to 24 at 2.17. So as I sketch this one real quick, 0 to 24. Again, these are my x values. Here's my z-scores. So 1, 2, -1, -2. So when it was at 2, I was at negative 2.17. 24 was up to 2.17. But it was crossing basically in between 4 and 5. So it's crossing about right here. So I had a lot of data points and it kind of curved. And then didn't it do like a little curve like this? Something to the extent of that? I hope I have it drawn right. The key things that I'll look for is your starting and your end, and note that it's definitely not linear. So is this data set approximately normal? No. No. Our normal probability plot is not linear, and the spread of scores, or the spread, I should say it this way, spread of, and the spread above, sorry, the x-axis is much greater than below the x-axis, suggesting the data is skewed to the right.